SpaceX launches NASA's most expensive planetary mission to date, we take a look at the final design for the Artemis spacesuits, and now that Starship has finally launched and landed, what's up next? As always, we'll have that and a whole lot more this week in Spaceflight. NASA has announced the end of an era in space communications, as the agency will no longer accept new missions for its Tracking and Data Relay Satellite System, or TDRSS. For 40 years, the network has been the backbone of near-Earth communications, supporting missions like the Hubble Space Telescope and the International Space Station. The TDRSS satellites are positioned far above the Earth's surface in a geosynchronous orbit. This allows satellites in low Earth orbit to have nearly continuous communications with the ground. The first TDRSS satellite was launched by Space Shuttle Challenger on STS-6 in 1983. Since then, NASA has added 12 more satellites to the network, the last of which was launched in 2017. During this time, the agency has improved the network with 3 generations of satellites, each carrying upgrades compared to the previous generation. But many of the satellites in the network are aging, and only 7 are still active. The first TDRSS satellite was designed for a 10-year mission, but was eventually retired after 26 years in 2009. Instead of upgrading the constellation with a new generation, NASA has instead decided to phase out the network completely. For future missions, the agency has turned to commercial partners. In 2022, NASA contracted 6 companies to develop and demonstrate space relay communication capabilities. Among these are companies with an established reputation in satellite communications, such as Inmarsat, SES, Telesat, and Viasat. But there are also 2 newer companies on the list, Amazon's Kuiper and SpaceX, which offered Starlink as a TDRSS replacement. The latter demonstrated this capability just last month during the Polaris Dawn mission. On that flight, Dragon was outfitted with a Starlink laser link terminal to tap into the Starlink network directly. It was the first demonstration of this capability on Crew Dragon. But if NASA's getting rid of TDRSS, what's the fate of existing missions like Hubble? Well, don't worry, NASA isn't pulling the plug on TDRSS just yet. While the network is no longer available for new missions, it'll stay online for at least a decade or so. That way, existing missions can still call home until at least the mid-2030s. By adopting these new commercial solutions, spacecraft and mission operators get to enjoy improvements like more bandwidth. And on future space stations, TDRSS handovers might be a thing of the past. TDRSS has made legendary missions possible for decades, so it will definitely be bittersweet to see it slowly being phased out. After much waiting, Starship finally launched this past week on its 5th test flight, and it was epic. After weeks of regulatory approval drama, SpaceX received the launch license for this mission just the day before the launch. Liftoff of the combined Starship stack of Booster 12 and Ship 30 took place on October 13th at 12:25 UTC from Starbase in Texas. This launch, just like the previous 3 flights, took place on the first attempt, with a few delays within the window, but still on the first attempt. The ascent of Booster 12 also featured no engines out and a clean flight all the way to stage separation. The sunrise views and the clear weather offered quite a show, and possibly for the first time, we were able to see the blue Methalox plume on Raptor as the rocket went uphill. The hot staging was also a success once again, with Ship 30 igniting all of its 6 Raptor engines and Booster 12 turning back for its boost back burn. This time, though, it went back all the way to the launch site. This was the first time it came back to land, so of course it was also the first time that we were able to spot stuff like the engine shielding literally glowing from the re-entry heat. As you know by now, Super Heavy isn't designed to perform an entry burn like Falcon 9 does, but I guess now you know why Falcon needs to perform a burn like that to protect itself. Despite some damage to one of the booster chines and some of the outer Raptor engines, not keeping themselves in shape, so to speak, the booster successfully performed its landing burn and landed in one piece in the launch tower arms. Now, we'll come back to what happened next with that vehicle in a minute, because while all of that was happening, Ship 30 continued to burn with its 6 engines on its way into space. The ship successfully inserted itself into a near-orbital trajectory that brought its re-entry over the Indian Ocean, just like on the previous 2 flights. This re-entry was the proof of fire for Ship 30's revamped heat shield that was aimed at solving the issues from Ship 29's re-entry. Despite this overhaul to the heat shield, some burn-through was still observed in one of the forward flaps of the vehicle, though not as aggressive as the one that we saw on Ship 29. Streaks of the backup ablative material were also visible in the camera feeds, indicating that some of the primary heat shield tiles on the vehicle had either fallen off or had broken and let heat go through. For this flight, SpaceX also performed more materials testing and experiments on Ship 30. The company confirmed that they had installed tiles covered in aluminum in certain places on the side of the vehicle. These would allow SpaceX to understand how hot it gets in those places as aluminum melts at the temperature that stainless steel starts to become weak. While SpaceX didn't say why they were doing this, it wouldn't be surprising if the aim was to remove some patches of tiles from the side of the vehicle to later introduce hardware to catch ships. We'll also discuss that in just a minute. Despite the damage, which again was still less substantial than on Ship 29, the vehicle made it all the way through re-entry and performed its landing burn in the Indian Ocean. According to SpaceX, this landing burn was different from the one on Flight 4, and it was aimed instead at keeping the ship in one piece for as long as possible in order to gather as much visual data from its heat shield as possible. Now, whether this worked or not, we don't know. But the vehicle was definitely on target as one of the SpaceX buoys in the area captured it blowing up right after it tipped over. Definitely an exciting way to put an end to another successful flight. But going back to Booster 12, it thankfully did not blow up after landing, and even though a small fire developed on the aft section, it was put out within minutes. The booster was safed and then lowered onto the orbital launch mount later in the day. After a short stay there, the vehicle was then removed from the launch mount and rolled back to the Mega Bay. So now, for the first time, SpaceX has a flight-proven Super Heavy booster and can take the opportunity to analyze it and get as much data out of it as possible. Soon after the catch, Elon reported on X that the booster, despite some of the visible damage, was doing great. He also implied that some of the engines would also be sent to McGregor for testing after their flight. This successful landing and recovery made Super Heavy the second orbital-class rocket booster to propulsively return to Earth after SpaceX's Falcon 9. Now, this is of note given that both rockets are by SpaceX. None of the other upcoming rockets with propulsive landing for their boosters were able to get there in that second position in the nearly 9 years since the first successful Falcon 9 booster landing. With Starship's fifth flight now complete, the company is getting ready for the next flight with Booster 13 and Ship 31. One piece of good news that came out of all of the regulatory drama is that the current license and environmental approvals also apply to the sixth flight of Starship. The FAA pointed out that SpaceX's changes for this upcoming flight still fall under what has been approved for Flight 5. So, unless SpaceX decides to radically change its mind, safe to say we're probably not going to have to deal with more of this drama, at least for now. Booster 12's successful catch prompted a lot of people to wonder when SpaceX may try to catch a ship. Thankfully, Elon referred to this upcoming milestone while talking on X about Starship, saying he hopes for that to happen early next year. But as always with Elon's timelines, take that with a grain of salt. Another thing to look forward to are launches of Starlink satellites on Starship. Right before this latest launch, SpaceX filed with the Federal Communications Commission for a modification of its current license to operate Starlink's second-generation constellation. This modification includes the addition of upgraded Starlink satellites, which are dubbed as Starlink V3, with the capability to provide gigabit connectivity thanks to larger and more powerful antennas. These are the ones that will eventually fly on board Starship, and given that the paperwork is already being filed for this, it's safe to assume a launch of Starlink satellites on Starship may not be that far away. Whatever and whenever all of this takes place, you can be sure that we'll be covering it all here at NSF. This week, Axiom and Prada unveiled the final design for the spacesuits that astronauts will wear on the moon under NASA's Artemis program. The unveiling took place as part of the International Astronautical Congress that took place this week in Milan, Italy. We'd seen an early version of this suit a year ago, but Axiom showed it with a dark cover on its outer layer on purpose to hide some of the proprietary technology that it's using on the suit. The Axiom Extravehicular Mobility Unit, or AxEMU, is part of the company's contract with NASA to deliver the spacesuits that astronauts will wear while on the surface of the moon during the agency's Artemis 3 mission. This spacesuit builds upon the Exploration Extravehicular Mobility Unit, or XEMU, that NASA has been developing for over a decade. Axiom used the technology and experience from that suit to develop this one, which is why they both kind of look similar. Another team, made up of Collins Aerospace and ILC Dover, was also selected to build a spacesuit for NASA, and their early design actually looked different than XEMU. That team, however, pulled out from the contract earlier this year, so it's all on Axiom now. This suit by Axiom obviously contains increased mobility, as will be necessary for a lunar EVA, and it also features the latest advancements in materials technology and textile techniques. And that is where Prada comes into play. Now you might be wondering, why is a fancy clothing company developing a spacesuit? Well, the reason is because they know a lot about textile materials and techniques needed to create clothes. A spacesuit requires not just expertise in engineering to keep someone alive, but also expertise in choosing how to put together the materials that make it up in the first place. I mean, the company that created the spacesuits for Apollo literally made women's bras. That company would then go on to make even more spacesuits for NASA during the shuttle era, and those are the ones that the agency currently uses on the ISS. Now, if you wish that these folks were the ones that were still making the suits instead of Axiom, well, remember the team that I mentioned that dropped out of the spacesuit contract? Yeah, this company was actually on that team. Now, while Axiom's design might be finalized, there are still a lot of tweaks needed, and the company will continue training with it for a while until it's time to use the suit on Artemis 3. Axiom is also well underway on its joint training sessions with NASA astronauts and SpaceX using Starship hardware, where they will all rehearse the procedures to be carried out during lunar missions. Now, whether these lunar missions will occur on time or not, well, only time will tell. This week, NASA named 2 different teams to assess the architecture proposals for its Mars Sample Return mission. The first of these 2 teams, the Mars Sample Return Strategy Review Team, will be led by former NASA Administrator Jim Bridenstine. This team, formed by members external to NASA, boasts a wide range of backgrounds, from members having previously been at positions of leadership within the agency to people with a high level of expertise in fields relevant to the mission. This team will examine options for a complete mission design based on studies that were granted earlier this year, and that we covered in a previous episode. The team will eventually release its findings in a report by the end of the year. They'll be supported by the second team that NASA formed, which is the NASA Analysis Team led by David Mitchell, Chief Program Management Officer at the agency. This team is formed by people from within NASA and will provide input to the Strategy Review Team wherever needed. Once the Strategy Review Team releases its findings and recommends an architecture for the mission, the Analysis Team will work on estimating the cost and schedule of said architecture. This will, hopefully, be one of the last stops before NASA finally chooses a Mars sample return plan that's cheaper and is completed more quickly than originally planned. The studies the teams will review are from a wide range of companies and types, ranging from the old trusted Jet Propulsion Laboratory and old space companies like Lockheed Martin and Nothrop Grumman, to new space companies like SpaceX, Blue Origin, and Rocket Lab. It is interesting, but perhaps not surprising, to see that NASA is now asking its former administrator, Jim Bridenstine, to lead the consultant team. After all, he's now working as a consultant. Although it has been in the plans for several decades, the Mars Sample Return mission was pretty much kickstarted during his time as administrator. Near the end of that term, NASA launched an independent review board on the mission as costs started to balloon beyond those originally projected for the mission. The findings from this review board forced NASA to change plans on the architecture in 2021, yet this didn't seem to work. This is because a second independent review board had to be formed in 2023, and it also found that even that new plan wouldn't work. So that's what's brought us to today, and we once again have even more review teams and even more analysis experts, which actually pretty much sounds like a typical government experience, to be honest. But this is a big deal of a mission, and NASA doesn't have the resources to do it fast unless it's done cheap. But doing it too fast and too cheap could mean that the mission may not succeed. Now, if there's at least one positive change from this time around, though, it's that NASA, for once, has also asked the industry to come forward with their ideas. They've reached out to external sources from industry to academia, asking for ideas and seeing what comes up. So, will third time be the charm? Now let's take a quick glimpse at some other stories across space, starting with VAST. Riding on the heels of last week's announcement, VAST has unveiled its Haven 2 station design. Haven 2, meant to succeed the company's upcoming Haven 1 station, will be multi-modular and based on the same design concepts as their first station. Its first phase will see 4 modules similar to the Haven 1 station launched into orbit over a period of a few years towards the end of the decade. These modules will be longer than Haven 1 and will contain 2 docking ports, allowing them to be docked to each other to form a larger station. VAST then plans to launch a larger 7-meter wide module to act as the core module for the second phase of Haven 2. The 4 original modules will then separate from each other and dock to the core module in a cross pattern. The third and final phase of the station will see another extra 4 modules like the original ones launching and docking to the station. This will allow for some of these extra modules to be specialized and have custom hardware installed. The timelines are definitely ambitious, so here's hoping that all goes well for VAST. From 2, SpaceX's human spaceflight mission around the Earth's poles has been delayed to March of 2025. The announcement came this week through the mission's profile on X. From 2 was originally scheduled to fly in December for maximum visibility of the South Pole, but according to the statement, quote, "The new timing allows us to take advantage of more favorable weather conditions required for a safe launch and return to Earth for human spaceflight missions." The mission profile, a human spaceflight in polar orbit around the Earth, would likely impose changes on the launch and recovery procedures and probably drove this decision. SpaceX, however, has not yet disclosed what this would entail. This week, NASA announced the planned schedule for commercial crew missions in 2025. The schedule calls for SpaceX to fly the next 2 crew rotation missions to the International Space Station. These will be Crew 10 and Crew 11, with the first taking place no earlier than February 2025 and the second taking place no earlier than July of 2025. Now, on the 2025 schedule, there's also room for a 3rd commercial crew mission towards the end of the year. You may also notice that none of the other flights went to Boeing's Starliner. Regarding this, the agency said, quote, "The timing and configuration of Starliner's next flight will be determined once a better understanding of Boeing's path to system certification is established." While a decision has not yet been made, this slot in the schedule could be used to fly Starliner again if the agency considered it to be necessary. For the moment, they're keeping their options open. The European Space Agency showed an incredible image from its Euclid space telescope this week, and it's only a teaser of what's to come. The image is a mosaic made from 260 individual observations. Euclid took all of these images over a period of only 2 weeks earlier this year. Stitched together, the image covers more than 500 times the area of the full moon, and it does so in incredible detail. The image contains roughly 100 million light sources, which are galaxies and individual stars in our Milky Way. However, it's only 1% of what's planned for Euclid's entire mission. The telescope will map 1/3 of the sky with the goal of studying the influence of dark matter and dark energy on the universe. To do this, it needs to observe many, many galaxies, and the newly released image is only the start. Euclid started mapping the sky earlier this year following its launch in summer of 2023. Its mission is scheduled to last 6 years, so there are many, many more of these pretty images to come. Arianespace has begun stacking of the vehicle set to fly on Vega C's return to flight mission. Vega C last launched in December of 2022, carrying the Pleiad Neo 5 and 6 satellites. However, its second stage, the Zefiro 40 stage, failed during its burn, turning the rocket's second flight into a total mission failure. Nearly 2 years later, a bunch of testing and a redesign of the Zefiro 40 stage, everything is now ready for the rocket's return to the pad. Here's hoping there's no failures this time though, as this mission is also flying ESA's Sentinel-1C satellite. This is a rather expensive Earth observation satellite that needs to launch as soon as possible in order to replace the capabilities lost with the loss of the Sentinel-1B satellite. Needless to say, we'll be hoping for the best outcome. Now let's take a look at the space traffic this week and see what's coming up next week in spaceflight. Starting off the week on October 11th, we had the return of China's Shijian-19 capsule. It touched down at the Dongfeng landing site in China at 2:39 UTC, marking the end of a 2-week mission. This was the first flight of China's new generation of recoverable science experiment satellites. The capsule is designed to fly 15 times, carrying up to 600 kilograms of recoverable payload. It also has space for 200 kilograms of unrecoverable payload. As for the payloads on this mission, well, not much information has been released. But we do know that on board the capsule were some plant seeds and microbial passengers to test the effects of microgravity and radiation exposure. Additionally, the flight tested new space technologies and carried space science experiments. Right on the heels of Starship, we also had the highly anticipated launch of Europa Clipper, NASA's mission to Jupiter's moon Europa. On October 14th, a Falcon Heavy lifted off from Launch Complex 39A in Florida. Notably, this also happened to be SpaceX's 400th launch. It took a lot to get Europa Clipper into its target orbit, even for a Falcon Heavy. This mission flew in a fully expendable configuration, with Center Core Booster B1089 completing its first and only flight. The side cores, boosters B1064 and B1065, both flew for their 6th and final time. Clipper has now started a 5.5-year journey to Europa, where it will study the Jovian moon in detail. With this mission, NASA hopes to discover whether the vast oceans below the moon's icy surface have the right conditions to support life. The spacecraft is also equipped with cameras, an ice-penetrating radar, and several other instruments to study the moon inside out. A few days before this flight, SpaceX had received approval from the Federal Aviation Administration to resume flights with its Falcon rockets, even though it didn't need it for the NASA-licensed Europa Clipper mission. The FAA has thus simultaneously closed out the mishap investigations for all 3 recent Falcon 9 anomalies. With permission to fly, SpaceX launched its 100th mission of the year on October 15th. The Starlink mission took off from Florida at 6:10 Universal Time and took 23 Starlink V2 mini satellites into low Earth orbit. The booster flying this mission was B-1080, which flew for its 11th time. It successfully touched down on the deck of SpaceX's drone ship, a short fall of gravitas. Just over 2 hours later, SpaceX launched another Starlink mission from California. This time, it launched 13 direct-to-cell satellites and 10 regular Starlink V2 mini satellites. The mission's booster, B-1071, ended its 19th mission by successfully landing on drone ship Of Course I Still Love You. With this mission, SpaceX also shattered 2 of its own records, the first being the shortest time to perform 3 flights in a row. The last 3 Falcon missions all took place within 16 hours and 15 minutes. The previous record of 20 hours, 2 minutes, and 22 seconds had been set in March with Crew 8, Transporter 10, and Starlink Group 641. But if you include Starship Flight 5, it was also the shortest time with 4 back-to-back launches at 43 hours and 56 minutes. The prior record was set in June with Starship Flight 4 and 3 Starlink missions in 82 hours and 42 minutes. With the 2 Starlink launches this week, SpaceX has now launched a total of 7,105 satellites, of which 647 have re-entered and 6,150 have moved into their operational orbit. Later that day on the other side of the world, a Changzheng 6A launched from the Taiyuan Satellite Launch Center on October 15th at 11:06 UTC. On board were 18 communication satellites for the Qianfan or G60 constellation. This was the second launch for that constellation, which is often referred to as the Chinese version of Starlink. The initial constellation is set to be completed by 2027 and will have nearly 1,300 satellites, but there are plans to expand the constellation to a massive 12,000 satellites in the future. Next, we had a Changzheng 4C launch from China, also on October 15th. Liftoff occurred at 23:45 Universal Time at the Zhoushan Satellite Launch Center. The passenger on this flight was one civilian remote sensing satellite for the state-sponsored China High-Definition Earth Observation System. The satellite is said to be outfitted with high-resolution instruments that can be used for, among other things, land census, urban planning, crop estimation, and disaster prevention. Going into next week, we'll have a Starlink launch later today. Falcon 9 is expected to lift off at 23:31 UTC from Space Launch Complex 40 at the Cape. The flight will carry 20 Starlink satellites into low Earth orbit, 13 of which have direct-to-cell capabilities. A Falcon 9 is set to launch OneWeb's 20th mission this week. Fittingly, the 20 internet satellites are scheduled to launch on October 20th. The launch will be conducted from Vandenberg with the 39-minute window opening at 5:09 UTC. Next week, we also expect Crew 8 to finally come back from the International Space Station. The Crew of 4's return was delayed multiple times due to Hurricane Milton, as well as unfavorable weather conditions in the splashdown zone. At the time of recording, Dragon is set to undock from the station on October 20th at 7:05 UTC and splash down off the coast of Florida a day later. However, there are hints that this might delay even further based on marine notices. And wrapping up the week, a Falcon 9 is set to launch another batch of Starlinks on October 21st. This mission will lift off from Florida during a 4-hour window opening at 22:40 Universal Time. And that's your weekly update of spaceflight news. I'm Elysia Segal for NSF, and I'll see you all again next week to recap this week in spaceflight.